to fill in the feedback form, you can do it at the end of session. I'll send the link in chat again, just for anyone who joined late. Okay. So today we're just gonna wrap up methods and then we'll quickly go over class inheritance. And then we'll be covering like Pygame sprites. Okay. So kind of just like a quick review, methods make it easier to organize the code. I would say like the biggest difference between these two examples is that for a method, you just have the like function defined within the class, which makes it a method. So, and you can like access it with self. I would say in terms of like lines of code, you don't actually get, it's not actually less lines of code, but it's just like a little bit more organized. And kind of like a quick reminder, just remember to use self in like the initiation and basically every single method you define in a class. Like you can actually make methods without the self keyword, but then they just won't be able to access like any attributes of the object, which is not very useful most of the time. Okay, so I guess the new part here is that you can also have methods within a class like access other methods. So it's kind of like when you use a function to call another function. So like in this example here, the diagonal method basically calls on the objects move x and move y method, right? So like in order to move diagonally, you need to move a space in the x and the y direction. So yeah, so methods calling other methods is basically like functions calling a function. It's pretty much the same. Okay, so that brings us to our first quick question. Okay, I'm not gonna give any hints, but just like be careful about remember stuff from the previous sessions or session, single. Okay. Guess we should quickly go over the answers there. So the obvious ones are you're gonna have self in the initiation, right? Self in the eat to call the eat function and self to call the byte function. And then and the trigger ones might be you also need self.fruit and self.color to say that like set the variable's fruit name to the sorry, not the variable, set the object when an object is created, set the object's fruit name to whatever parameter this is, right? And then finally we want the self function in the byte, which is kind of like pass in the object itself to the byte function so that it's not a great example here, but if, for example, if you actually wanted to access like I don't know self.color here, then you definitely need this the object itself to be passed into the byte function. Because if you don't have an object, then you're like, well, what object's color are we referencing, right? So just like a quick thing is, once again, if we don't have these self keywords here, you can actually call the eat function, but how it would work is you would do something like fruit. You'd be calling the class itself in something like fruit.eat, right? And then fruit.eat would call byte and it would print crunch. But if you want to be able to like create a fruit, say, I don't know, apple equals fruit, and then call the method on the apple itself, then we need the self function. Otherwise, it just doesn't know what to do. Yeah. All right,
Ryan, you're not
next.
sharing your screen right
Oh,
now.
that's silly. Okay. I need to remember to do this. Yeah, so quickly, just as I was saying, you want to have a self here, 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 right? Um, right. Yeah, so hopefully that made sense. I think some people kind of just maybe forgot some of the places where you have to have the self keyword. And once again, like what I was mentioning about having the self keyword here is like if you don't have it, then there's no object being passed in. So if you wanted to access like one of the object's variables, like self.color, you actually need to have self like pass as an arguments, right? Otherwise, like there's no like whose color are we passing in? Okay. Um, yeah, so next we have inheritance. So specifically it's class inheritance. And let me just skip forward. Okay. So without inheritance, if we wanted to make like 4 classes, we would have to kind of type everything from scratch. But the idea is like with inheritance, if you have what's called like a parent class, um, then if you know like a bunch of subclasses, so for example, if you have like, I mean, the example here is an Eevee. I hope you all play Pokemon. If you don't, hopefully I'll try my best to explain it. But it's like all of these creatures, they have like a name, right? And they have like a creature type. So what they're saying is, since we know all of these creatures are going to have the same thing, let's have like a parent class that kind of like has all of these features to begin with. So I think like a more, um, what is this? Maybe like a more relatable analogy is like if you have an animal, like all animals are probably going to have some number of legs. It's like even if they have 0 legs, it's still a parameter that like all of them will share, right? But then there's going to be more specific things to what's called like the child classes. So these 3 over here are going to be what they call child classes of the parent class. And how you know that they're child classes is you actually pass like a argument to this. You put like the parent class name in these brackets. Like, before we would initialize classes just like this, right? So that space is actually for the parent class. And so how this works is this Flareon here, like it actually has a name, type, growl, and tackle just because it's a child class of the Eevee. But then it also has the Ember and Fire Fang, sorry, not classes, methods, yes, methods, like that are exclusive to this creature itself. Yeah, so basically it saves code, makes life easier. Okay. So yeah, I think I already explained most of this. Yeah, so this is kind of how it would look in code. So first oopsie. First we initialize or we create the Eevee class, right? We have initialization with the name, the type, and one of the starting methods. And so now when we create the Flareon class and put Eevee as the parent class, how super.init works is, I believe there's like a few caveats to this, but in simple terms, you basically are able to pass in like a name and a type to the parent function's initiation, if that makes sense. So, um, yeah. Yeah, okay, sorry. So super.init, I think, is basically saying like, okay, use this like all this initiation code in the Eevee's initiation function and kind of just like copy and paste it here. Like obviously it doesn't, we don't actually type it out, but it's like saving space. Then we have, you know, a couple extra functions that we want. And so once again, Flareon, like if we created a creature called, I don't know, C equals Flareon. Whoops. I hope you guys can, yeah, you should be able to see me typing in the speaker notes and pass some, you know, variables. Then it would also have access to the tackle function, right? So c.tackle. Bleh. Okay. So yeah. Exactly. There's the typed out example. I don't have to type it myself. All right, so our first exercise is going to be create a parent class and then create like a child class that basically inherits from the parent class. So we want the child class to have this thunder attribute, or not attribute, sorry, the thunder method, and then we want like all the stuff from the Eevee class to be inherited. And let me think. I think there's like a file. Okay, there might not be a file, but it shouldn't be too hard to make the Eevee class. All right. I think we can use like 15 minutes for this. Okay, there we go. All right, so I feel like I'm gonna guess most people got it or were able to figure it out with the help of their mentors, so I will not be going over the solution. Okay, so next up we have Pygame sprites. So Pygame sprites are kind of like, if I'm correct, they're just like a class that makes like a lot of things easier. So they have a couple built-in what are they called again? I'm just gonna call them properties as the image suggests. So these are like image and rectangle. So basically every time you create like a Pygame sprite object, it's gonna like expect that you pass in an image and a rectangle property most of the time. And there's also like a couple of built-in methods which are the draw and update functions. So the draw function basically there's like it's like an easy way to draw things to the canvas instead of having to like, you know, create a like a rect and then draw that rect. It's an easier way. And then the update function is kind of like where you put in all the data that you have to update. And there's basically, once again, since it's a built-in method, you can just do like, if you created and I'm just gonna start typing like, where do I start typing? In speaker notes. Okay. So you created like an object. And you could have, basically you would define update. And you would put like collision detection probably goes in update. And you know, things like player interacting with their environment. It's like, oh, did you get take some damage or did you get like some coins or something? All of that would go in update. And then there's in the while loop, you'd just call like object or whatever the object's called dot update, and then just run all of that code. Okay. Oh yeah, okay. A couple things I didn't mention. There's like sound. You can add sound and animation. I mean, animation's kind of just like you cycle through images. I'm not sure what it means by behaviors. I think that's just like more complex code for your character or whatever. Okay. So a sprite is basically like a 2D object on the screen. So like in this example, everything that's outlined in a blue box is basically a sprite. Usually sprites have like bounding boxes or like they have collision detection. That's part of what makes them a sprite. Because like, this bush over here, that's kind of just part of the background, so wouldn't be considered a sprite. So one of the built-in functions for Pygame sprites is this thing called getRect. But basically what it does is usually it's used on an image. I'm actually not sure if you can call it on anything else, and basically returns like the X, or sorry, not the XY. It returns the width and the height of the image. And that way you don't have to like, find the width and the height of the image before you load it in. So in this example, the fairy class basically inherits everything from the Pygame sprite, made pre-built Pygame sprite class. And so I actually, just to clarify, this super.init thing is actually the same thing as typing like pygame.sprite. It's basically like typing the parent class's name and typing up init. So earlier when I mentioned like the with the Flareon example, I believe. Yeah, so super.init is actually just typing like ev.init. It's kind of like a placeholder for the parent class name, but it's like a shortcut because sometimes people don't want to like type the whole thing out, especially if it's like a longer one. So yeah. Whatever. And then there is the image which gets loaded in, and we'll explain that later. Okay, what else? I think there was something else I wanted to mention. Okay. Yeah, no. So I think I already mentioned this, like there's the update function, which is kind of like all pygame.sprite, or not function, sorry, method, all pygame.sprites objects will have it. And okay. Yeah, so there's a little caveat here, or not really caveat, but it's like the update function is called once every time we go through the loop, while like other functions, you can call them like based on, I don't know, say keyboard events or something. Yeah, I guess a quick thing is like usually how people use the update function is they'll have it like all the checks will be within the update. So you'll have like collision, you'll just run like collision checks. Maybe you'll have, I don't know, I can't think of a great example, but maybe you want to run like battle checks if you've got like a fighting game or something. So those sorts of things. Oh yeah, animation would also go in update. Okay, so now we're gonna just try like replacing one of the like our rectangles will actually get some images we can use in our game. So what we're gonna do is we're gonna go and download the fairy PNG. What? Yeah, okay, I'll try to go through this, but it might if you're on like a different different resource or something, or not resource, different computer, you might have to figure out yourself. But basically we want to download this. Okay, I'm just gonna save as. And you guys can all like do this at the same time. And usually you want to save the image like to an actual folder that you'll be doing your code in. Assets inside session. So the folder structure is not like super relevant, but what the slides are suggesting is that you create like a folder called assets. And I do not have a session 4 folder, so I'm just gonna put fairy PNG in that. And you want the folder is generally like separate from your actual code. So you'll see in the example how like main.py is outside of the folder, right? Okay. I'm just gonna copy and paste this for easy. Make it easier. Yeah, so. Okay, so what we want to do next is hopefully everyone it's best if you can follow along, but if you can't like type everything up this that quickly, it's okay. So basically I'll quickly explain like this is the initiation function once again. In this case there's no parameters, but usually it's like you might have like some parameters here, right? I believe. No, sorry. Yeah, I believe there are. Sorry, one second. Okay, so usually you actually put the parameters next to the initiation. Okay, so the first one is we're kind of giving the image locate. We're setting the image location as a variable, and so os.path.join. I don't remember the exact details, but this image location thing would look something like if you were to actually print it out, it probably looks something like assets/berry dot png as a string. So this os.path.join is just like kind of it's a function that goes into your folders kind of and sees like, okay, what is the file path? So it basically finds the file path and returns it as like a string. So adds slash for you. You can actually here we can actually print that to see it as well. We can just do like, I don't know. There's probably bad practices putting this in the middle of, we can just do that, right? And you can, okay. I do not think that worked. Did it work? No. Of course, yes, I need to call the function. You know what? I will not do this, but I'm pretty sure it would return like a string that just showed your file path, and you can actually put this as like you can put this directly into the image.load function. So instead of like image location, you can literally just do this if you know what the image location is. But os.path.join, I'm pretty sure if you have like an in between folder, if you have like another folder, you know, and you just put this in, it should figure out like how to get to that path. Okay. Yes, everyone who wants to try on their own, they can initialize a fairy, but I'm just, yeah. Okay. And a quick like thing here, convert alpha, basically, I'm pretty sure, I might be wrong on this, but I'm pretty sure just like make sure that you can actually see the transparent parts of the image. And as a speaker notes kind of say, it's like make the image load faster as well. Okay, brings us to our next quick question. Oh, and yeah, I'm gonna be testing that while y'all do the quick question. There you go. Okay. I'll have to screen share again, don't I? Okay. All right, so I quickly tested that, and so actually, just a correction, ospath.join does not figure out the in-between folders. If you actually want to join like multiple things, you have to type it. So it's like assets.images. So if you had like an images folder, let's see, is I'm not gonna actually try to type it because I'm not very efficient with this. Yeah, yeah. Was running missing from this, right? Okay, sorry, I was not looking at the quick question. Does somebody want to just like share the answer? Super. Yes, yes. Okay, makes sense. Yeah, so I guess there's just like there's no initialization. Sorry. Okay. So next we're going to be covering groups. And so kind of groups take advantage of the built-in updates and draw methods because basically if you make like a group, so you say enemy equals enemy and then so that's the object, and then you create like a group for all of the enemies. Then you can actually call like functions or not function methods. Yeah, they're methods on the baddies group. It's actually a group is kind of like a list, except there's like a few built-in functions that like I think you can check for collision, and then you can be like, oh, does a player like collide with any of the objects in a given group? Whereas like if you wanted to implement that using just a list, you would need to like put in a bit more code. So yeah, that's why you should just group like everything. Sorry, not groups. Put all the objects into groups. Okay, so basically an example is like when you create an object, you can create a group, which is like fairies equal pygame.sprite.group, right? So this is like pygame.sprite is accessing the sprite library itself, and then .group is basically the function that it's calling. Update method. Would you mind elaborating on your question? Yeah, sure. Okay. That's probably a good idea. Like you can probably ask your mentors in the breakout rooms. Great. Fairy from our fairy class. Okay. So like I mentioned, one of the things that you can do with a group is you can call like a draw function on it, which basically like because the draw function is like built into all of the what is it, pygame.sprite.sprite objects, then you can kind of think of this as like going through this function so like fairies.draw basically goes through like uh every single object in this group and then just like calls the draw method on it. And it's kind of a lot of it's kind of pre-built, so like as long as you have the two things that you need is you need an image attribute or not attribute. Is it called an attribute? Okay, I forget. You need an image and you need a rectangle. And then if you have those two things, then the draw function will always work. And the argument here is basically like which canvas you want to draw to. So like I've never actually seen somebody do this before, but you can actually have more than one like screen when you're back in the initialization, near the top of the code. Don't have a great example right now, but you'll know there's a place where you do like screen equals window of X size. So you can actually have more than one, but usually people don't use that. Okay. The other thing, like I mentioned, is you can have like the update function, which like you can put whatever you want in there, and then having once again this update function of the group just calls on the individual update functions of every single object within the group, right? So this update function is specific to the object, so you could have like another class that's like, I don't know, do something else. And you could put them both in the same group, and obviously they would update like separately. Okay, and that brings us to there's actually kind of 3 exercises. So I think what we'll do is, since, okay, how about we kind of like, we can like try to split up the time and then come back once just to kind of check in. So we can do like 15 minutes for this exercise, and then, try to get as much done as you can. And then I can kind of like maybe walk through a solution, and then we can do the second one. And as you'll notice, like these things are, I believe they're not for Ignite points purely because like the exercise answers are already in the GitHub, but just get creative, like do something. If you already have some game idea, maybe this can be kind of like your start for a game idea. You definitely don't have to use like the exact sprites here, like you can find your own images. Usually PNGs are best. And then, there's like a bonus thing at the end, which I think we will not have time to do in session, but like anyone who wants to take that on can, and then you can just like ask your mentor for assistance. Yeah. So we'll do 15 minutes, we'll come back, go through like a really quick solution, and another 15 minutes should be good. Okay, so I may have lied about these sessions not being for exercise points. I'm actually not sure. So I'm not going to walk through a full solution because I did not find anything on, I did not find an answer online. So these might actually be worth points. But I guess like some hints, and I guess, so I believe it's actually, we're planning to do all 3. It hasn't been decided yet, but I think it would just be like kind of like a breakdown. And I mean, let's see. I think that they kind of build on each other. So it'll probably be like the first one's worth some points, and then the second one you kind of need to I guess you can kind of submit like the updated version of the file. I mean, technically the first and the sprite one and the platform one are, you can do that. You don't actually have to do both of them, but I mean, if you can do one, you probably know how to do the other. So basically what we wanted to do is, okay, 1 second. You want to create another file, and am I screen sharing? I don't think I am, which is fine. I don't need screen share, but you want to create like another file, probably call it like something like player.py, and then you create the player class, kind of like we did with the Eevee. In the initiation, you want to make sure you remember like the super.init. You want to give it an image and a rectangle, and then to give it movement, if you remember like using the, if you send in the last one, do you get all the points? Sure, but I think it's just like, if you're gonna do that, just like, I guess add a comment and say like, okay, all the previous stuff has been implemented, and then yeah. But I think, yeah, we can do that. I don't want to spend much time because might as well just get more breakout room time. And I'm gonna assume that most people didn't finish the first one yet because it is take quite a while. So pull, and so I think we just want to do the end of, oh, actually 1 second. 2023. Yeah, okay. I will just quickly share this before we finish off. Okay. Yeah, and I believe the Flarebot is up now. Sorry, not the Flarebot, the Emberbot. So you can try to go into the Discord bot commands channel, type in basically your group number. And I guess day of the week would be Wednesday. So you just do exclamation mark group set Wednesday and then your group number to get into like a private channel with your mentor. I mean, I'm gonna assume most of you already have like group chats, hopefully. Okay, one more thing is there's actually gonna be something called the Canis Hackathon from November 17 to 20. And it's basically, how do I describe it? So I'm actually not too aware of the exact details, but usually they kind of present you with like some sort of challenge. So in this case, it's going to be related to data visualization, and you kind of like, come up with a solution. So this one's aimed at beginners. Like if you're interested in doing some sort of like, I'll just call it a coding challenge, then I would recommend like checking this out. Unfortunately, there's no like other, you can just click on the link to get more details. So yeah, basically you can check the last slide of the Flare session 4. If you're interested in doing some sort of like coding challenge, there's definitely prizes as well. It's beginner friendly, so definitely check it out. And if you haven't filled out the feedback form already, just like I'll send the link again in the chat, but I'm pretty sure everyone has it. And yeah. Yeah, quick note. So for the bot notes, like make sure the bot channel, just make sure you type everything in lowercase. Oh yeah, okay, and then we have the end of session poll.